Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for today is January 4, 2024, and the time is almost 5:30 a.m. Okay, my topic for this session will be a random topic, and this will be an interesting one. And this is under the so-called study of direct current circuit. Okay, for those of you who are taking up electrical engineering or plan to take up electrical engineering, this is for you guys. Okay, let's proceed. The random topic for this morning will be a problem on direct current circuit, and this will be the circuit for this morning. We are given two voltage sources here. They are both batteries, so it's a direct current circuit. And the resistances indicated on the circuit, this is 0.2 ohm, this is 0.4 ohm, and the load of the center is with the value 5 ohm. The problem is asking what will be the current passing through the 5 ohm load if the voltage sources is actually 12 volts for the left hand side and 18 volts for the right hand side. The problem is asking what will be I sub 5 ohm equal to. The current passing through the 5 ohm, if this is 12 volts and this is 18 volts. And what will be the proper direction of the current passing through the 5 ohm load? Of course, the current passing through the 5 ohm load by inspection, it should be downward. So we will be expecting a current that it will be downward because this is a minus polarity, this is a plus, this is a minus, and this is a plus. If the current or if the voltage source on the right, the usual direction of the current should be from minus to plus, so it should be something like this. And for the left hand side, since this is minus, this is plus, we assume it is like this, but we don't know if it's downward. But the other sure for the right hand side is that the current delivered by this 18 volts will be something like this. That's for sure. We don't know for the left hand side because this is 12 volt. Because this is 18 and this is 12 volt. Right? This is more powerful than the left hand side. Okay, the problem is asking what will be the current passing through the 5 ohm load here. Okay, let's try to bring out the solution of this one. The solution that I will be presenting will be the so-called Kirchoff's voltage law. Meaning to say, we will designate two unknown currents to the circuit and we will apply Kirchoff's voltage law in the so-called formulation of the required equation. Then we will solve the two equations simultaneously. So we could solve for the current delivered by voltage source number 1 and the current delivered by voltage source number 2. Then we try to see or to go back to the circuit and let us determine the proper direction of the current. So it could either be that the current passing through here will be I1 plus I2 if our assumed direction is correct, or it could be that it is I sub 2 minus I sub 1 maybe. Okay, let's try to bring out the solution. By using the so-called Kirchoff's voltage law, okay, we will be taking the summation of the voltages considering one loop at any given one time. In here, I will designate that the current circulating on the left loop will be I sub 1, and I assume that the direction will be it's clockwise, right? Clockwise. It goes with the direction of the clock. For the right hand side, I assume that the current will be, it is not clockwise, it is counterclockwise. It is against the direction of the clock, right? So this is counterclockwise. It's from minus to plus, so it should be like this. For the left hand side, this is minus to plus, so it is clockwise. So this is clockwise and this is counterclockwise. Okay? So the current on the left loop will be designated as I sub 1, and the current on the right hand side will be designated as I sub 2. As soon as we compute for the value of I sub 1 and I sub 2, we will just take the summation, okay, and that will be the total current passing through the 5 ohm loop. Okay, let's try to consider I1 loop. For Kirchoff's voltage law, the designation will be something like this. This is the sigma notation, this is capital letter B, and this should be equal to 0. If for the meantime, we will consider the left loop. Well, we forget this one first, right? We cover this one. We will just take the summation of the voltages considering the left loop, okay? So it will be, we follow the loop of I1, right? So this 12 volts is a voltage source, so this is actually plus 12 volts, right? The voltage drop across this point to ohm will be the current passing through it times I sub 1. This is a voltage drop, right? So it should be the product of current I1 times the resistance it passes through. The voltage drop across this will be I sub 1 times 0.2. Okay? And what will be the voltage drop across this one? Across this. Across the load. It will be the total current passing through this 5 ohm load times the resistance value, which is 5 ohm. And what is the current passing through this 5 ohm load? From our designation, it is I sub 1 and I sub 2, right? So this is the total current passing through the 5 ohm load. I sub 1 plus I sub 2. Multiplied by its resistance, 5. This is also a voltage drop. So this is a voltage drop, it is a voltage source. And this should be equal to 0. Okay? That's considering the left loop. So if we try to simplify this one, this is how we will be distributing this one. This will become minus 5 I sub 1, right? So, 5 I sub 1. I sub 1 times 5 will be negative 5 plus 0.2, that will be 5.2 I sub 1. I expedite a little bit. And negative, this 5 times I sub 2 will just be simply 5 I sub 2. This is now plus because these are both negative. We transpose it to the right, then we try to rearrange it. So they are both positive now. 5.2 I sub 1 plus 5 I sub 2. And for the left hand side, this will remain on the left, but we rearrange it to this will now be on the right. Okay? And to simplify the resulting equation, we will multiply all the terms by 1 over 5. So 5.2 times 5 will be 1.04 I sub 1. And 5 over 5 will be 1. The coefficient of I sub 2 now will just be simply 1, or just simply I sub 2. And 12 over 5 will be 2.4. We call this equation number 1. So we are on this circuit, but it seems we are now on the process of the so-called algebraic process. Okay, we formulate the equation, we simplify, and we call that resulting equation to be equation number 1, involving two linear unknowns, I sub 1 and I sub 2. So assume for the meantime that we are on algebra, so it seems this is x and this is y, but since we are on this circuit, we designate the variables of the unknown thing to be I sub 1 and I sub 2. We are solving for current. Okay, consider the I2 loop. Okay, this one. This is a voltage source. Again, we use Kirchoff's voltage law. We take the summation of the voltages considering the right loop. This is a voltage source, so this is plus 18. Okay. The voltage across this point for here will be the current passing through it times its resistance. So it will be I sub 2 times 0.4. We are using the equation voltage equal to IR, right? Because we are taking the summation of the voltages. And the voltage drop across this, considering the right loop, will be the total current passing through it times 5 ohms. And the total current passing through it will still be, from our designation, this is downward. Okay, this is downward, right? So it should be I sub 1, I sub 2, right? Same direction, times 5, and they should be equal to 0. Again, I expedite a little bit. This is negative 0.4 I sub 2. Okay, and there is a negative 5 I sub 2 here. So if I will try to combine, that will be 5.4 I sub 2. The coefficient will be 5.4. And there is a 5 I sub 1 here. Okay. So this is 5 I sub 1. Negative, we after the combining, we put it in the right, and we try to rearrange. So actually, they are now both positive, like on the first one, 5 I sub 1 plus 5.4 I sub 2 equal to, we maintain this one on the left, but we rearrange it, so this will now be on the right. So this is equal to 18. Then I want to simplify the resulting equation. I will try to multiply all the terms by 1 over 5.4. 5 over 5.4 will be 0.926 I sub 1. And 5.4 divided by 5.4 will just be simply 1. So the coefficient of I sub 2 will just be simply 1. Or just simply I sub 2. And this should be equal to, camera, 18 over 5.4 will be 3.33. Okay, we call this equation number 2. So after taking the summation of the voltages on the right loop, again, we formulated another linear equation involving I1 and I2, and we call that equation number 2. To solve for the current I1 and I2, we solve simultaneously. We apply our knowledge of algebra. It's either that we will be using elimination by substitution or subtraction or addition. In here, I prepare the so-called elimination by subtraction. So I will be writing equation number 1 underneath equation number 4. 1.04 I sub 1 plus I sub 2 equal to 2.4. I'm following this. Again, I write it underneath because I would like to perform the operation subtraction. Okay, so I will place this horizontal line here. Then I will try to perform the operation subtraction. 0.926 I sub 1 minus 1.4 I sub 1. This should be negative 0.114 I sub 1. The operation is subtraction, so this is I sub 2 minus I sub 2. This will now become minus, right? So if I perform the operation subtraction, we will eliminate I sub 2 because this cancels. This is now 0, or just simply like that. And this should be equal to. For the right hand side, it will just be simply 3.33 minus 2.4. This is bigger than 2.4, so this is 0.93. And if we try to divide this by the reciprocal of negative 0.114, okay, this one cancels. So I sub 1 will be 0.93 divided by negative 0.114, and the value is a negative 8.16 amperes. It's a negative value, meaning our assumed direction for I sub 1 was actually wrong. So actually the correct direction of I sub 1 is this. It is upward. And this is 8.16 amperes. Okay? because this voltage source here is more powerful than this 12 volts here. So instead of driving the current going in this, it should go like this for voltage source number 1. Okay? Then solving for I sub 2, we will be using equation number 2. So 0.926 times the computed value of I sub 1, which is negative 8.16. We carry the sign. The only significant, there is no such thing as negative current. It is just that the negative sign indicates that our assumed direction was actually wrong. So this is multiplied by negative 8.16 plus I sub 2 equal to 3.33. 8.16 0.926 plus 3.33, okay, it will add up to 10.886 amperes. So the value of I sub 2 will be 10.866 amperes. This is the correct direction. It's downward. Okay? So from the resulting value now, this is downward and this is upwards. So the current passing through the 5 ohm load now, well, it will still be I sub 1 plus I sub 2, but we must have to carry the proper sign. And the value of I sub 1 is, instead of a plus, it is a negative 8.16 amperes. Okay, it is upward. It is against I sub 2. The value of I sub 2, we assume that I sub 2 was actually downward and it was correct. So we maintain the sign plus 10.866 amperes. And what will come out for the current passing through the 5 ohm load will be 2.726 amperes. Okay, that is by using Kirchoff's voltage law. A while ago, I checked my solution by using superposition theorem. Superposition is like this, as a brief summary, because we will be checking if this is correct or not. We might have some made mistakes on the simplification, but I assure you that the solution was correct because I solved this one by using superposition. Okay, by using superposition, I will short circuit voltage source number 2. Then I will try to compute for the current passing through the 5 ohm load due to the 12 volt. And my computation comes out that the current coming from the 12 volt source, okay, by using superposition is 1.54 amperes. It is downward by using the superposition. And again, by using the superposition, I will cover this one, I will short this one. Then I will try to compute for the current coming from the 18 volt source. And I could compute for the current passing through the 5 ohm load due to the 18 volts. And as per my computation and my notes, the current given by the 18 volt source, when the 12 volt source is shorted, it is 1.18 amperes. And it is still downward. Okay? So, they are both downward. Right? This is 1.54 and this 1.18. And this is the 5 ohm load. So the total current passing through the 5 ohm load by using the superposition theorem will be 1.54 plus 1.18. And what comes out is still a 2.72 amperes. Same as the solution by using the so-called Kirchoff's voltage law. Oh, this is a very interesting problem. I think you have understood it very good. And this is just an illustration on how the concept of Kirchoff's voltage law is applied in solving for currents on a given particular component in the circuit. Okay, for those of you who would like to subscribe to my channel or watch my videos on my channel is at youtube.com/@RookTVJ. If you want to share it, please click share. Good morning from Los Angeles.